Welcome back to The Explainer. Today, we're tackling a totally critical transition for developers and builders, moving from casual experimentation to building rock-solid, production-ready applications with the Claude API. Okay, let's dive into this. Because building production apps with Claude requires a completely different mindset than just casually chatting in a web interface. When you're chatting, you are the human error handler, constantly adjusting things on the fly. But when you use the API, your code has to do all that heavy lifting for you. And let's face it, your code doesn't exactly have your human intuition.
We need to bluntly shatter an illusion right off the bat here. The rules of standard web chat simply do not apply to the API. In a chat interface, if Claude gives you a slightly weird response, you just type, "No, I meant it like this," and you fix it immediately. You are the error handler. But when you're wiring an API into your software, a single unexpected sentence can break your entire parsing logic and crash your app. We literally have to stop thinking like conversationalists and start thinking like engineers.
Here's our roadmap for today. We'll cover chat versus API rules, designing system prompts, building error tolerance, mandating structured outputs, followed by a real-world success story, and finally, taking your prototype to production.
Part 1. Chat versus API rules. A new mindset.
So the crucial point here is that the API requires us to think systematically right from the start. We're looking at three massive differences. First up, instruction persistence. In a normal chat, you often have to remind the AI of the rules as the conversation kind of drifts. But in the API, your system instructions are permanent. They sit in a dedicated layer and you do not need to rewrite them with every single call. Second is error handling. A glitch in a chat just means you hit refresh, no big deal. In an API, every single error, whether it's a rate limit or a formatting issue, must be handled programmatically by your code, otherwise the whole system just halts. And third, output rigidity. Chats are fluid, right? They're conversational. APIs, though, require rigid, predictable data that your software can reliably read and process every single time.
Part 2. Designing system prompts. The foundation.
This right here is the absolute foundation of your application. It's really where we see the biggest difference between an amateur prototype and a true production-grade approach. Think about the weak method. It's basically like throwing all your rules, formats, and restrictions into a messy suitcase on every single API call. And the result? Totally inconsistent behavior. Sometimes the model follows the rules, and sometimes it just gets distracted by the user's actual prompt and skips them entirely. On the flip side, we have the strong, engineered method. Here, you design a dedicated system prompt layer. This acts as the permanent, unchangeable rules of engagement. When you separate the system rules from the user input, the behavior remains perfectly consistent across thousands of API calls. And the best part? The user message only ever needs to contain the immediate question or task at hand. It's a total game changer.
So, what actually goes into that dedicated system layer? Well, a strong system prompt requires three specific definitions. First, Claude's role. Who is it acting as? Are they a senior data analyst, a helpful customer support agent? You have to define the persona. Second, boundary rules. You absolutely must explicitly state what topics or tasks Claude should not respond to. This is your guardrail. And third, output format rules. How exactly should the final answer look? By locking these three things in the system prompt, your application becomes incredibly stable and you never have to repeat these instructions again.
Part 3. Building error tolerance. Planning for failure.
In the world of APIs, hoping for a 100% success rate is, well, it's a critical engineering mistake. Networks blip, things happen. You have to plan for failure. Let's contrast the two approaches here. The weak approach is building your app with this fragile hope that the API will just never throw an error, completely failing to handle error states. And the result? A tiny API hiccup takes down your whole system and ruins the user experience. The strong approach, though, is defining proactive retries and fallback behaviors for specific error types. For example, if you hit a rate limit error, your code shouldn't just crash. It should automatically retry, say, 3 times with an increasing delay between each attempt. If you get an invalid format error, your code should catch it, maybe show a generic, polite error message to the user, and just keep the main system running smoothly.
Part 4. Mandating structured outputs. Breaking free from text.
Now, what's really interesting about this slide is that to succeed, we have to stop treating the AI as a simple text generator. Think about the weak approach, asking Claude for free-form text or casually saying, "Hey, give me a list." When you do this, you're forcing your application to use incredibly fragile parsing logic to read that text. The very moment Claude adds a conversational, "Here is your list" at the top of the response, boom, your code breaks. The strong approach is explicitly demanding a defined data schema. You don't just ask for a summary, you demand a structured response containing exact fields, like a title, a summary, and a priority level.
You strictly instruct it to provide only this structure and absolutely no additional conversational text. This guarantees your code can reliably process the data every single time.
Part 5. Real-world API success. The field story.
To really hammer home why these pillars matter so much, let's look at an anonymous case study. A team was trying to automatically classify incoming customer requests. We really have to ask, what actually happens when you ignore these engineering rules in a live real-world environment? When you just leave everything up to the user prompt and hope for the best. Well, for this particular team, it resulted in daily chaos.
The team admitted, and honestly, we've all been there, quote, "Some days the parsing code just crashed because the response format changed slightly." And this brilliantly illustrates the dramatic pain of the weak approach. Because they were embedding their instructions right into the user messages and leaving the output format as free-form text, Claude was treating the task like a fluid conversation. One day the output was a bulleted list, the next day it was a paragraph. Their app's parsing logic simply couldn't keep up with that, leading to endless software crashes and, of course, frustrated users.
But then, they implemented the exact framework we're talking about today. They moved their role, boundaries, and rules into a dedicated, permanent system prompt. They enforced a strict data structure for the output. And the result? Parsing errors were completely eliminated. By shifting from a chat mindset to an API mindset, they literally transformed a buggy, unreliable tool into a perfectly stable, automated workflow.
Part 6. Prototype to production. The final synthesis. Let's move to that and see how this builds into our final synthesis. Taking absolutely everything we've learned, we can distill this down to a definitive framework. These 3 shared steps are the exact lines separating a fragile prototype from a robust, production-ready system. Step 1. Fix the system prompt. Seriously, stop stuffing rules into user messages. Step 2. Plan for errors. Build in your retries in your fallbacks so your app bends instead of breaking. And Step 3. Structure the output. Demand strict data schemas and refuse conversational text. If you enforce these 3 layers separately, you're no longer just sending prompts, you are engineering a truly resilient system. So I'll leave you with this provocative thought as you look at your own code. Are your API integrations running on engineered stability, or are they just running on fragile hope? Taking the time to build these 3 pillars will save you countless hours of debugging down the road. In our next explainer, we're going to take this exact robust mindset and apply it to integrating with automation platforms like Zapier, Make, and N8N. You definitely won't want to miss how these structured outputs plug directly into those workflows. If you found this useful, like the video and subscribe to the channel. I'll see you in the next one.